And so tutor 3, supervised learning logistic regression, we stopped here, and I'm going to provide answers to those questions. So using data of Excel file related to lending club, develop a logistic model to classify loans of test sample into good and bad loans. So we have got 3 data files attached to this tutorial. We have worked on this 3 data file before: lending club train data, validation data, and test data. So remember that in our analysis, usually we divide our sample into 2 or 3 groups or subsamples. The training sample will be used for training model, basically. Validation sample will be used to check if the model is overfit or underfit, and the test sample is used to check the accuracy of the model in forecasting. Yeah. But in some cases, I mean, some practitioners don't use validation sample anymore, so they used test sample instead of validation sample to check if the model is overfit or not. And you need to take this one into account as well. So the way to divide sample into 3 sample or subsamples is also another concern in machine learning, how to divide with which ratio. If, for example, we have got 10,000 observations, how many percentage of this observation should be allocated to training sample, how many percentage to test sample. So usually they go for the ratio of 70 to 30. 70% goes for training sample, 30% goes to test sample. So if you have got validation as well, so maybe like 50% training, 20% validation, 30% test, or 60% training, 20% validation, 20% test sample. So there are some discussions on the literature about sampling. Be aware that there are different things that could impact on the performance of your model. Number one, the framework or the model that you use. For example, logistic, regression, or OLS, or decision tree, SVM, KMV, and etc. So framework is number one. Number two is actually the sampling, how we do sampling. Number three is the features that we use in developing models. And number four is the type of evaluation of models. So which metric that we use for evaluating models. So all these factors could impact on the performance of models. For example, if 2 user or practitioner use the same framework, both, for example, decision tree, and work on the same sample, but their the ratio of dividing the whole sample into 2 subsample, training and test, is different. One of them use 50-50, another 60-40, or a third practitioner 70-30, you shouldn't expect the same result. So I just wanted to mention that one as a point of concern. You need to take this one into account, that there are different things would affect on the performance of models, and one of them is sampling. All right. Okay, so now let's go to a Colab. You can open your Colab in your laptop and follow me. If you have got any question, please ask. Don't hesitate to interrupt and ask your question. Otherwise, I keep going. All right. So this is the Colab. I already provided these notes on the canvas, so you can find it out. The name is AFV 7518 tutorial 3 logistic regression, and I explained line by line what each line of code and cell means and what it does for you. So let's start with the packages. So import packages, the first step. And let me change my monitor. All right, a second. More comfortable to work with this one. Share. Okay. All right, so we have got. Okay, so starting with the packages. So we have done it before. Um, the good news is that from now onward, for different techniques, I can tell you that 60%, 70% of the codes that you're using is the same. So you can simply copy, paste for the next type of, for example, machine learning technique, because the codes that we use is almost the same. And um, for example, next week we are going to talk about like um, SVM, for example, or KMV. So this cell, the next cell, this cell, for example, this one, we are going to use exactly the same lines of code there as well, so we can copy and paste. So be careful and understand that you need to know what we are doing exactly, what packages we are using, right? And it is very important because for different classification techniques, we are going to use different kind of packages as well. All right, so import warnings is the first one. So import warnings, warnings, filter warnings, ignore. As I said, this one is used to filter those unnecessary warnings which we can see in our output. So sometimes Python, uh, when we execute a line of code or a cell, it provides some comments or some kind of warnings which are not essential warnings. So there are kind of advisory warnings. So we don't want to see them in our output. That's why we use this line of code and Python simply ignore them. All right. Pandas as PD, NumPy as MP. Remember these two line of code. We have used them before and we are going to use them here as well. Uh, so remember pandas, PD is used for to work with the uh, data frames, right? And uh, NumPy is used to work with arrays, which is very important. And also we have got Seaborn, which is another data visualization library. And same as Matplotlib, it used for drawing graphs, but it has got more features. And you will see later that you can draw much more advanced graphs using this library, Seaborn. And matplot, pyplot as PLT. PLT also used for drawing graphs. Scale-learn is the library for machine learning. It's a very famous one. And from scale-learn module, we are going to download sub-module named linear model. And from linear model, the model that we are going to use is logistic regression. So logistic regression from linear model from scale-learn. And also the metrics for accuracy and performance evaluation, always from a scale learn. All right, metrics import this range of accuracy checks. So we have got accuracy score, recall score, precision score, F1 score. We explained them in our lecture notes, what each of them stands for. So, and also confusion matrix and area under ROC curve. Mostly we need this kind of accuracy scores, recall score, area under ROC curve, confusion matrix for our work. But for the sake of having um, actually a note for your future use, I provided all those metrics. And of course, there are more metrics that you can download from this library. All right, so the next step after importing library, so let's run this one again and again. If you see any kind of warnings which suggest that your library is not installed, you need to install them first by the code PIP. PIP install the name of the library. Depending on your RAM and computer speed, it takes quite a while. For me, it looks that my computer is too busy right now, so maybe I close some stuff here. Yeah. So once you see this green tick, it suggests that you're fine to go to the next step. So the next cell is to actually upload our samples into the work environment. So remember in Collab, what we do actually, we go here, table of contents. And here you need to press files. And then from your folder, just choose and drag these 3 Excel files. Ensure that your files are saved elsewhere. These runtimes files will be deleted when the runtime is terminated. So this is a temporary memory in the collab. So after finishing your your task or closing this collab, all of them would be disappeared. So keep this one into mind. So we uploaded 3 Excel files into our environment, and just you need to close that one. So for now, I have provided the code for you, but you know that we already mentioned. Okay, so we are going to create a data file named train, using which module PD, which stands for pandas dot read Excel. This is Excel file, and the directory or path of this Excel file is located here. So you need to copy it and put it inside the bracket. Of course, you need to use single quotes before and after this address. Why? Because there are strings, and strings always should come inside single quotes. So we have done this, guys, in these processes before, so I'm going to skip it. So we have got train, validation sample, and test sample. You can name them whatever you want, right? Based on your taste, the way that you feel, but you cannot change the right side of this equation, right? You cannot change anything here, but you can change the left side, whatever you want to call it. Also, we are going to make sure that all columns in these 3 sample files have got the same names. So that's why we use another array. We define an array, we call it calls. You can call it something else. But this right side, we put home ownership, income, DTI, FICO, and loan status as the name of these columns inside the bracket. In other words, we are defining an object, and we assign the value of this objects, which are in low home income, DTI, FICO, and loan status, to what? To the columns of these 3 data file. So train columns, validation columns, test columns should be equal to calls. So yes, please. Hello, you have question? All right, looks that. And then after class. After class. Okay, I don't understand. Is that question? Anyway, so I think
she's not aware that she's not muted. I think she's on a call.
You're muted. You're muted.
all right, sorry guys. All right, so we are assigning the name of these names to our columns, as I said. So if you print it, you will see what you have got as a result. And always remember, this print thing at the end of each cell is just for checking that we are doing the right thing. You don't need to print things necessarily, right? If you omit this actually or drop these 4 lines of code, your coding would be actually more clean, smaller, you know. So you don't necessarily need to print out things, but for the sake of checking, you know, we are doing right thing. For example, I want to see if my training data has got these names, my validation sample has got these names as the column names, and test sample the same. We just go and print them, right? And that's it. Okay, so as you see, we have got everything in place in terms of data. Now, what we want to do, we wanted to, for each sample, test sample, training sample, and validation sample, we want to separate features from the target. Features from the target. Target is what? Loan status, right? And features are the first 4 columns of each sample. So we call these guys X, X1, X2, X3, and X4. So we're gonna call them, for example, test sample X. X for training sample, for example, right? And we're gonna call this one Y. So X for training sample, which is actually the matrix of X, right? Matrix of X, including X1, X2, X3, and X4, is equal to what? Is equal to our training sample dot drop. So I'm asking Python to drop something for me from training sample, which is what? The last column, which is loan status, and comma 1. I explained already what this one means that I'm telling Python that you need to drop or delete 1 column for me with the name of loan status. If you put 0, most likely you won't have any answer. In this case, column, actually Python is looking for a row, not a column. Python looks for a row with the name of loan status to drop it for you because we don't have such a name. So you most likely receive an error. So this is the reason that we put 1. So drop is a function for dropping a column or row in Python. To distinguish between row and column, we need to use 1 or 0. So 0 means row, 1 means column. Clear for everyone? Please let me know if you have a question here, right? So X train, X validation or val, and X test. These are the 4 first columns of training sample, validation sample, and test sample. So for checking, we print the X val, for example. See, we have got just the first 4 columns, all right? And the same for example, train, X train. Yeah, so we have got them. Next step. Remember, in machine learning, for some methodologies, it's better to do centralizing. And in other words, what we are doing, we are making our features standardized. How we standardize our features, actually, the value of each variable for each observation minus the average of that value for all observation over a standard deviation of that feature for all observations. So through this approach, we standardize our features. I explained in the lecture, we don't need to do so for all machine learning techniques. One of them is, for example, OLS, and one of them is logistic. Even for logistic regression, as far as I know, it doesn't make that much differences between the final results. But for some specific techniques in machine learning, especially those which deal with distance, that I will explain later in coming lectures which type of machine learning techniques using this approach end up with better and smoother answers. So wait for me actually till that lectures I'll explain for you. So what we do here, we are standardizing. So as you see here, home ownership, it has got a binary value 0, 1. Income has got a continuous variable 0 to, I don't know, for example, $150,000. DTI is a ratio. FICO is a continuous variable between 350 to 850. They have got different units. By standardization, we make them all without a specific unit. In other words, those values at the end would be something between -3 or +3, all right? And as such, we would have better result for some machine learning techniques. So, um, so in this 3 lines of code, we are standardizing. And here we are defining our y variables or target variables. Remember here we separated x1, x2, x3, x4. Here we are separating our target variable from the original sample. So loan status as a column would be separated from training sample. We are going to call it y for training sample, y for validation sample, and etc. So we can again print to see what we have got as a result of standardization. All right, and let's see. So if you compare, for example, these values here, the original values of features with these values here, as you see, these values are getting closer together. It doesn't mean that there's no differences between homeownership, income, DTI, and FICO anymore. No, it means that the value are standardized and the value comes between -3 to +3, roughly speaking. And it would help to develop and train some models in machine learning techniques. Okay, and what else we have got here? Here also we ask for X-train shape. Shape is a feature attached to any data file in Python. By dot shape, you can find out what are the dimensions of that data frame. For example, X-train. Remember what was X-train? X-train is X1, X2, X3, and X4 from training sample. So we can see that X-train has got 7,000 observations and 4 features, right? This is what we expect. And Y-train shape. Y-train is just targets or loan status for our training sample. How many? 7,000. And it's just one. So that's why it doesn't have any value. It's just one column, right? Xval is the same. So 3,000 for validation sample, 2,290 for test sample. So by shape, you can find out the number of dimensions, number of observations in your sample, and the number of columns in your sample. So far, what we have done was to prepare our samples for running our model and developing our model, basically. So here is another piece of extra code. This is provided. So for example, if you want to see the frequency, the ratio of y equal to 1 to y equal to 0. In other words, how many percentage of your training sample, how many percentage of observations of clients in training sample have been good customer? Yes, please.
Sorry, please. I didn't understand exactly the 700 for 7,000,4 and this thing. I didn't get exactly what you meant there.
7,000 is the number of the, yeah. So it's,
for each of
remember
the,
in training.
Okay.
Yeah. Okay. Training sample. Remember if you look at these Excel files, let me open one of them. For example, train one. Wait a second. It should be open in Excel. All right. So. Okay, so Excel is opening. As I said, my computer is slow. Let me put this one here. Okay, so what is our X train? Let's see our X train. X train head. So see, we have got This is our training sample, right? And x1, x2, x3, and x4, right?
Mhm.
And the number of observation, the first 5 observation. If I say tail, so it goes to 6,999, which suggests that how many observation I have got in training sample? 7,000. Why 7,000?
7,000, yeah. Because
Yeah,
of the first
because
column is 0.
yeah, exactly. So I can use shape instead. Ah, it happened.
That wasn't
X,
spelled properly.
No
yeah,
bracket, the shape.
shape doesn't need actually brackets. Okay, so 7,004. Is that clear?
Okay.
Yes.
7,000 observation, 4 columns, right?
4
So
columns.
the
Yes.
ones with only 7,000, why is it like that?
It's actually Y train. So if you look at the Y train head, Y train head. Okay, it has got just one column, and it's an array. It's not data frame. That's why it doesn't actually tells you the number of the columns here, because it has got just one column. It's not a data frame as well. So see, the shape is also different. If I say X train, so X train has got, see, this is a data frame, yeah? This is the index, column 1, column 2, column 3, column 4. But this one is Y train, and it's not, it's just simply an array with 7,000 observations. The same, 6,999, including column 0. So we have got 7,000, and comma, a space means that it's just 1, basically. But because it is array, it doesn't tell you 1.
Okay.
All right, so let's, okay, so now we want to know what is the frequency. So we can count the number of 0 and 1 in our training sample using this function value counts, which count the number of 1 and zeros for you, basically. And, you know, the sum of the frequency is, for training sample is 7,000. So frequency, okay, let's see what is the result of this. As you see, it shows that that 1, so the number of observation with the lone status equal to 1 is 79%, comparing to 0, which is 20% of observation actually have been bad customers. So this is how we can find out this one, but it's just for the getting percentage and finding the number of 0 and 1 in one column. You can use this code. All right, so now we want to develop our logistic regression. Okay, so remember that we already downloaded logistic regression function from our module, related module, which was a scalar. Yeah. So I'm gonna call this one the left side. Again, same as always. You can call this one whatever you like and are comfortable, but you cannot change the right side. Okay. So logistic regression is equal to logistic regression. This is my function. And this function, as you see, if you click on Colab, not in Jupyter Notebook, Colab, it shows you different, they call it parameters that you need to fit. Some of these parameters are must. You have to have got a value for them. Like, for example, penalty. Penalty none, we put it equal to none. For logistic regression, simple logistic regression, always we put none. We have got some other versions of logistic regression, which are lasso and rigid, which we won't cover it here. They put it L1 and L2. So for now, we are just going to focus on none, okay? And this logistic regression will be used for most of your research purposes and etc. And the solver, we already talked about the solver before in the class, but again, this is the optimization approach we use to find out the best combination of the coefficients for your actually features in order to maximize the maximum likelihood or minimize the cost function. Okay, so Newton CG is the one that we pick up here. And so through these two, we define a new function. We call it logistic regression, which is going to fit a model for me a simple logistic regression using Newton CG as the optimizer. So now, same as before. So this is a new function for me. We define this one. So we're going to fit a model using training sample and actually using training sample x's, which are features, x1, x2, x3, x4, and y, which is the target. All right. Why the sequence is like this? Why x train first, y train later? Because this is how the developer of this module designed this one. Okay, we just follow the approach they defined for it. So X train first, Y train later. Maybe you find out in other packages for developing, for example, OLS regression, they say Y first, X later, right? So it's up to that package and how it is designed. So logistic regression fit model. And for checking and seeing actually the intercept and coefficients of this model, we just need to type print logistic regression intercept underline logistic regression coef underline. Again, all of them are defined by the package. We cannot change them at all. We cannot customize them. If I put, for example, double underline, most likely I would receive an error here, right? So we need to follow the instruction of that package in order to get the best actually fitted model. So this is our fitted model. This is intercept and the coefficient of x1, which was, I think, the home ownership, x2, which is the income, x3, which is DTI, and x4, which is FICO. As it is expected, the only coefficient with negative value is DTI. Why? Because higher DTI, higher debt to income ratio means what? The probability of default or being bad client is more. So this is a indirect nexus or relationship between DTI, debt to income ratio, and being good customer, right? And other coefficients are positive as it is expected. So higher income, for example, means that the probability of being a good customer is higher, right? Or for example, higher FICO, credit scoring, means that probability of being customer is much more. So now we have got developed model, and these are our model. So anytime in your, for example, yes.
Sorry, sir. So
okay.
Talking about this logistic regression based on the fitted model, can it also depend on the reference outcome we have in mind? Because here now, I'm taking it that we are assuming that the reference outcome is the one that is for good customers that won't default. Are there models that can also have a case whereby we are looking at the default now, as in those, the zero is now the reference we are using, like those who default? Is it possible to build a model in that way too, or must we always assume the positive outcome?
Of course, you can, if it depends, as you said, depends on how you define 0 and 1. In this case, good customers are 1, bad customers are 0. Usually, personally, in my all works, I do reverse. I consider 1 as the bad customer, 0 as good customer. And as such, your result should be exactly negative. So here would be negative, this one would be negative, this one would be
positive. Okay.
Yeah. And you can test it. You can change the in the Excel file, you can change directions and see the result would be different. Exactly would be reverse. Okay.
All right. Thank you.
No worries. And okay, so now we have got fitted model, right? And now we can predict. We can predict. So I'm going to predict what? The probability or loan status. This is our prediction using that fitted model. So logistic regression is the function we defined with a specific penalty and a specific optimization approach. And now we want to ask this function based on these coefficients, all right, to predict, okay, the Y train for us. Okay, so logistic regression dot predict proba. This is, see, when I click on it, it comes automatically. It means that it is already written by developer of this function. All right, so we cannot change anything on the right side again, but you can change the name in the left side based on your taste, based on how you are comfortable to name these guys. All right, so logistic regression predict X train. What is gonna do for me? It's gonna to multiple these coefficients times the first row, for example, here for the first guy. So it would be, let me show you quickly, 1.4162 plus 0.1453 times this one plus 0.033 times this one plus, you see what I mean, all right? So plus this one times this one and so on and so forth. And all result would be saved in a data file called ytrain predict. Okay, so when I'm going to do the same for validation and test sample. And when you run this one, so this is your actual Y. This is actual, what happened in reality. This is the predicted one, right? The result of predicted is a two-dimensional function, actual array. It's a 2D array. What are these 2D? The first one is the probability of non-default or probability of being a bad customer. Sorry. The first one is the probability of being bad customer, and the second one is the probability of being good customer for the first client in our training sample, right? Okay, so again, I repeat myself. The result of this is, as you see here, if I click on it, it shows me the result. The result is, is an array. The shape of array is 7,000 because I have got 7,000 observation, but it provides two columns. The first column is the probability of being 0, and the second one is the probability of being 1. Okay, the same for other observations. All right, so now I have got these results and I can create. So after having the probability, remember, we still do not have 0, 1. We have got the probabilities. So what we are going to do?
Back.
Yes.
Sorry to take you back. So I just wanted to be very clear. So you're saying that the first column, that's the first column array output is probability of being a bad customer, and they said that's 0.19, and the second one 0.808 is probability of being a good customer.
Yes, exactly.
Okay, thank you.
Or it's, let me tell you, generalize it. The first one is the probability of being 0, and the second one is the probability of being good, or 1. Yeah. So it depends on how you define 1 and 0. Let's make it generalized like this. But again, what is provided here, it doesn't give me final answer. What I am looking for, I'm looking to classify customers into 0 and 1. Yes. So what I'm supposed to do here, we need to define a cutoff point. So for example, I say if cutoff point, for example, cutoff point is 0.70 or 70%. If this one, the second row, is more than 70%, that client is 1. If it is less than 70%, that client is 0. Okay, so now that's why we need to define cutoff point in order to classify our clients into these groups of 0 and 1. Okay, so after having that, after setting a threshold or cutoff point and classified our customers into 0 and 1, so we have got a predicted 0 and 1, and we compare it with the actual 0 and 1 and check the accuracy of our model. This is the whole process is going to happen. All right. So let me just quickly mention what is happening here for you. So remember, after developing each model, you need to check if that model is overfit or it's a good model. Sometimes the models are overfit because we use many different type of features, and as such, the model is overfit. So I showed you in Excel during lecture. Here we can use Python to check this one. So we are going to create a vector of maximum likelihood for training sample. All right, and using the NumPy dot log. So log is the logarithm, is a function in NumPy module, comma. Before doing this for me, do this for me. To remember, in Excel we had counts if or count if. Instead of count if in Excel we have got where. So from NumPy there is a function where I'm telling Python if y train. What is y train? This is the actual numbers, right? Actual loan status. If y train is equal to 1, okay, y train predict 1 means what? See, this is my y train predict. Y train predict 1, it means that pick up the second probability. Remember, in y train predict, we have got two probabilities, probability of being 0 and probability of being 1. And remember, Python counts from 0. So the first column is 0. The second column is 1. The first column, the first row is 0. The second row is 1. This is how actually Python counts. Python counts from 0. So that's why when here we say if y train is equal to 1, which means that the actual loan status is equal to 1, use what? The second probability. Otherwise, so it doesn't tell basic, we don't write otherwise, but by putting comma, we say pick up the first one, which we are suggesting Python, if y train is equal to 0, put this one, or consider that one, okay? And take logarithm, all right? So for example, in the first case, right? The first client is 0. So we are asking Python to pick up which one? This one, and take log of 0.19. The second client is 1. So I'm asking Python to pick up this one and take logarithm of 0.7784. The third client is 1. So I'm asking Python to pick up this one and take logarithm of that. Do the same for all of them, and we will end up with MLE vector val. So just to show you what is this one, let me drop this and put them here. Okay, I'm gonna run this one and then just type to see if we can see the values assigned to maximum likelihood value. So see, maximum likelihood vector train is a one array, actually one dimension vector, which means it has got just one column. All right, and each column is actually a logarithm of one of these two values. Depends on the actual number. If the actual number is 0, logarithm of the first. If the actual loan status is 1, this one. So we have got this, all right? And so I just wanted to show what is this. And then cost function. We do what? Remember I showed you in the Excel file. We are going to sum all this vector train, sum all of these values over the number of observations. So we take an average and minus that average. So make it cost function. Yeah. Minus of the sum of all these values over the number of observations. So len yTrain actually shows what? This is a function to show the length of a sample. So length of yTrain was 7,000. So what it does basically, sum all these values over 7,000. So basically takes average of all these values and make them negative. So we have got cost function. And as you see, the cost function for all these three samples are next to each other. They are very close. It suggests that the model, the fitted model, developed model is not overfit. All right. So this is how we can end up with the decision that if our model is overfit or is good model, basically. And then we have got a series of codes to decide about, okay, if our model is a good model or bad model. So I provided the lines of code for you, an explanation for each. I'm going to go through them, but it might take a little bit more time. So if you want to leave, that's fine. The lecture, by the way, would be recorded. So we have got different threshold. So you can decide about thresholds. You can put whatever you want to put here, from basically 0.3, 0.4, 0.75, 0.80. So this threshold will be used to classify our clients into good and bad. Remember how? Using that prediction values for each client that we already explained. And here I'm asking Python to create a data frame because we want to put all those metrics and measures in one single data frame. We call it results. So for creating any data frame in Python, we use the function PD, sorry, the module PD and the function data frame. Okay, PD, data frame, all with cap, right? These two should be cap. So what is the name of this, the columns in this data frame? So threshold, 0.75, 0.85, 0.85. If you add more threshold, it's going to be more here. And accuracy, true positive rate, true negative, false positive, and etc. Whatever you want to put here, you can put. It is absolutely customizable. All right. There's nothing standardized here. You can add measures, you can decrease or drop measures. It's up to you. All right. So in the first column, remember, the name of the first column is threshold. I want to assign values to this first column. What are the values? The values are the values of this array. So the result threshold should be equal to threshold. So one way to understand what we are doing is to isolate actually the lines of code. So when you isolate them, you will understand what we are doing. As far as we are not in a loop environment, you can see for example, here, results. Yes, again, typo. Let's see. Yes, see, this is what I'm creating. We are creating a data frame named results, and we are assigning values to these columns one by one, right? So for the first column, which is threshold, the values should be equal to threshold that we already defined here. Yeah, I can change this one to, for example, TS and assign TS to this one. You see, answer is the same, right? So this is the way you can understand what we are doing step by step. And then here we are going to use a loop. You know, loop in programming is very important because it makes your life much more easier and faster, because we are going to do the same step 3 times for each threshold one by one, right? So that's why we use loop. So we set up the counter equal to 0. So counter starts from 0. Remember, in Python, always counting start from 0. And the process is going to iterate 3 times. If you have got further, for example, 0.90 here, so this one would be 4 times, right? You can have as many as number of thresholds you like. So for I in threshold, we are assigning each value in threshold to I, one by one. So in the iteration 1, it starts with 0.75. Okay? We are telling that predicts, create predicts. What is predicts? Again, we use if counts in Python. Logistic, regression, predict, proba. We already have this one for X test. So we are checking accuracy of model on our testing sample, right? So I'm telling Python if the value of, remember, what is the result of this? The result of this line of code is here, right? You have got an array, 2D or two-dimensional array, or we have got an array with 2 columns. The first column is the probability of being 0, and the second one is the probability of being 1, right? So I'm telling Python if the value of the second column is more than I. What is I? We are in the first round of iteration, which means that more than 0.75. Then put 1. Otherwise, put 0. So simply, we are asking Python, if this guy is more than 0.75, put 1. Otherwise, 0. For example, for this one would be 1. For this one would be 0. For this one would be 1. For this one would be 0, right? And then create confusion matrix. Again, this is a pre-written code, confusion matrix. We are just, it's a pre-written function. Confusion matrix is developed already. We are not developing anything. We are just using developed functions, right? In sklearn library. Whitest is the actual values of 0 and 1. This is what in reality happened. Predicts are what we are predicting based on our model and the threshold value, and put labels 1 or 0. So these labels would be 0 or 1. Sample weight is none. Why? What is the sample weight? Simply, sometimes we have got very unbalanced sample. For example, the number of the zeros are 1% of the whole sample. In that cases, we want to give those failed or bad customers more weights in our sample in order to avoid overlooking by this model. So in that case, we give those actually zeros more weight using an array. For our cases, we usually don't do that, all right? But if you're interested, you can, add an array. Later on, I will explain for you how. And this array gives more weight to the zeros, for example, in our sample. But for now, because our test sample, remember, the ratio was 30%, 70%, which is fine, right? And so confusion matrix, y-test, predict over number of, length of y-test, which is 7, body test was 2,229. Basically, we are finding what? The ratio of true positive, true negative, false positive, and false negative. So all of these values would be recorded in this CM, and then we are going to ask Python to print for us. Print confusion matrix threshold I. So these are for actually expressing or presenting the results, right? Print confusion matrix, which is a string. You can type whatever you want here, doesn't matter. I. So in the first round, we are still on 0.75. Also print for us CM, and print an empty line, mostly for separating different things. I will explain later this one, how it works. And then this CM has got is a matrix of 2 times 2, basically. Remember, confusion matrix is true positive, true negative, false positive, false negative. It gives you 4 numbers, 4 percentages, yeah? So I'm asking Python to print true positive, which is located in where? In the first column of the, in the first row and the first column. The second one is false negative in the first row and second column. And here we have got false positive in the first, in the second row, first column. And finally, here we have got true negatives, which is located in the second column and second row. So all of them would be printed. Okay. And finally, so we have got these results where we were looking for. Now, remember in the results, this data frame, we were creating this data frame. We want to assign the created values to the data frame results. So iLoc, again, is a function to find out a specific place in our data frame. So results iLoc, I think I printed somewhere here. Results iLoc, maybe here I print results at the beginning again. I don't know if I have it. Results, no, sorry, results. Yeah, so we are assigning the estimated value to these functions, right? So, sorry, to their places here. So for example, accuracy score. See, here is accuracy score, right? I want to put it in the iLoc J. We are in the first round of iteration. So J is equal to 0, right? 0 means first row. J 1, it means that first row, second column, right? Because as I said, Python start with counting from 0. So the first column is already taken by threshold. So the second column is going to be filled by accuracy score. And likewise, recall score, or this ratio. So 6 columns. So the first column, column 2, 3, 4, 5, 6, and 7, right? All will be fitted with these values or be filled by these values. And then J plus equal to 1 means that go to the second round of iteration, which means that it starts with the second threshold, 0.80. And do the same, fill these values here in the second row and finally third row. And once we basically run this code, all right, we have got something like this, okay? Because here we said print confusion matrix for threshold, print confusion matrix, so printed confusion matrix for threshold I 0.75, yeah. Print CM, so CM is printed here. This is CM. CM is a matrix of 4 cells. It has got 4 cells, and print an empty line just to make a separation between them, right? Just wanted to put this one to separate these 3. And finally here we say print all matrix. So print all matrix, it's printed. And print result T. So we transposed this data file. Original one was something like, let me see if I print result. Let me go ahead again, see, give it a go. Oh my God, my spelling keeps giving me errors. So this is the original one, right? Result. So we transpose it in order to have a better look of the final results. Yeah, so I can skip that one simply and run it again. Any question, guys? So it looks a little bit tedious and complicated, I know, but believe me, it's if you go overview it one more time, you will see that's not very complicated. And we have got one more thing, which is calculating area under rock curve, which we are going. Yes, I have to jump to another meeting. That's why I'm going to stop here, but I will cover this one for you in the next tutorial. Basically, we use this line of codes in order to create area under rock curve for our model and estimate it, which is 0.65, more than 0.50, which is a random prediction. So it's a random model. Our model performed better than random model, which is a good news, but still we cannot say it's the best model. We can compare it with other models that we are going to develop in future. Okay, guys, any question? All right. If not, so I'm gonna stop here and stop recording.